This is lesson 9-8, factoring by grouping. We're learning a new method today to factor other than finding the factors of our last term that add to be our middle term, or simply pulling out a GCF, or in the last lesson, the last lesson we had those rules, and the lesson before that in 9-6 we used FOIL. But FOIL doesn't work on a 4-term polynomial like the one we have right here. The reason it doesn't work is because FOIL is only for a trinomial, and here we have a 4-term polynomial. So our only method that we have to use for factoring a 4-term polynomial is a method called factoring by grouping, and that's the method we're going to learn today. So the first thing I'm going to do is I'm just going to group my first 2 terms together, and then I'm going to group my last 2 terms together. And then in each group, I'm going to pull out the GCF for that group. So the GCF of 6x cubed and 3x squared, I noticed that the greatest common factor for 6 and 3 would be 3, and the greatest common factor for x cubed and x squared is x squared. And then I'll rewrite this. 3x squared times what gives me 6x cubed? Well, 3 times 2 gives me 6. X squared times x gives me x cubed. And then 3x squared times what gives me 3x squared? Just plus 1. So 3x squared times 1, 3x squared. So that's my first group. My second group, I noticed that the negative 4x and negative 2, they both have a common factor of a negative 2. So I'm going to pull out a negative 2 from negative 4x and from negative 2. So negative 2 times what would give me negative 4x? Well, positive 2x. Negative 2 times 2x, negative 4x. Negative 2 times 1 would give me negative 2. Now we can look at these and we see, and I'll give these new names. I'm going to call this term A, and I'm going to call this term B. So this is A times B, and then minus, and then I'll call this, it needs a new letter because it's a different number, C, and this is, again, a B. So by renaming these terms, or by giving these terms a different letter, we can see that in this first polynomial, they have a B, and in the second polynomial, we have a B. So I can, again, pull out another GCF. And that GCF now is going to be this 2x plus 1. I can pull out that 2x plus 1 from both of these. So I now have 2x plus 1 times, and then what's left? 3x squared minus 2. Okay, it seems like I did a little bit of magic here. This is our answer, in fact. And then how do we always check to see that the answer is correct? Well, we just have to FOIL. So let's FOIL these 2 binomials and see that we do in fact end up with 6x cubed plus 3x squared minus 4x minus 2. So 2x times 3x squared, that does give me 6x cubed. 2x times negative 2, negative 4x. And then 1 times 3x squared plus 3x squared. 1 times negative 2, negative 2. Then I just need to rewrite this in standard form. 6x cubed, because I have no like terms, plus 3x squared minus 4x minus 2. And you see we do end up with what we started with. I know this is a totally new concept, so let's try another one. Looking at quick check 1A, they want us to factor and then check our answer, which is what we just did. So again, since we have 4 terms, the only method we know to use is to factor by grouping. So you group your first 2 terms together, and then you group your last 2 terms together. And in our first 2 terms, I see the GCF of my first 2 terms is 5t cubed. And you'll notice that if you look at your variable and the exponent on your variable for each term, you're always going to use the lowest exponent on your variable, so t cubed. And then 5t cubed times t would give me 5t to the 4th. 5t cubed times plus 4 would give me 5t cubed times 4, 20t cubed. And then we look at the second one. Well, it looks like I'm going to be pulling out a positive number, and they both have the factor of 6. That is the greatest common factor, so plus 6. 6 times what would give me 6t? 6 times t, 6t. And then 6 times 4 would give me 24. Notice again what happened. We ended up with this common factor here, this common term of t plus 4. So I'm going to pull out that t plus 4, so I have t plus 4 times, and then I just combine these together to make another binomial, 5t cubed plus 6. And again, to check it, all we have to do is FOIL. So this is our answer, and then we're going to FOIL to check it. T times 5t cubed, 5t to the 4th, t times 6 plus 6t, 4 times 5t cubed plus 20t cubed, 4 times 6 plus 24. And then we rearrange to put it in standard form, 5t to the 4th plus 20t cubed plus 6t plus 24. And again, we see it is the same thing that we started with. All right, let's try another. So we're doing the same steps here. The first step is always group your terms. So group your first two terms together and group your last two terms together. Then find your GCF. So the first is group first two terms and last two terms. The second step is to find GCF for both groups. That's what we're doing right now. Find the GCF for both groups. So the GCF of 2w cubed and of w squared is actually just w squared. They don't have any numbers in common since there's that imaginary 1 in front of w squared. So w squared times 2w would give me 2w cubed plus 1, w squared times 1 would give me w squared. Then for my second group, I see they both have subtraction signs. So I'm going to factor out a negative 7. That's the GCF for 14 and 7 is 7. So I factor out a negative 7. Negative 7 times 2w, negative 14w. Negative 7 times 1 gives me negative 7. And again, you see we end up with this common term here, this common binomial, 2w plus 1. So we're actually factoring out the 2w plus 1 from each one of our sets here, from each one of our groups, and then what's left over becomes its own binomial, w squared minus 7. And again, we can check it simply by FOILing. So this is your answer. And then we FOIL to check it. 2w times w squared, 2w cubed. 2w times negative 7, negative 14w. 1 times w squared plus w squared. 1 times negative 7, negative 7. Rearrange it to put it in standard form. 2w cubed plus w squared minus 14w minus 7. And we see we did do it correctly because we ended up with what we started with. All right, example 2. Now they're telling us to factor completely. We're factoring completely here. So what we notice is that actually now all of our terms have a GCF. If we look back at those ones that we just did, there was not a common factor that you could pull out from all 4 of our terms in this one, or a common factor we could pull out from all 4 of our terms in this one. Neither in the very first one that we did. But now that we're to the second example, we can see that actually all 4 of our terms have a GCF that we could pull out. And anytime there's a GCF you can pull out from all of your terms, we always want to do that, whether it's a trinomial, a binomial, or in this case, a 4-term polynomial. So I can see that all of these have in common definitely a t. And then what else? Could we divide all 4 of these by 2? Certainly, but maybe there's a bigger number. Could we divide all 4 of these terms by 4? 8 divided by 4 is 2, 12 divided by 4 is 3, 16 divided by 4 is 4, and 24 divided by 4 is 6. So definitely 4 works as well. 6 doesn't work because of the 8. 8 doesn't work because of the 12. So 4, and actually 4t, becomes our GCF. So notice if you look at all of your variables, if you're going to pull out a variable GCF, you have to pull out the one with the lowest exponent, which in this case is a 1. So we're pulling out a 4t from all of our factors. We have 4t times what gives you 8t to the 4th? Well, 2t cubed. 4t times what gives you 12t cubed? So that's a plus 3t squared. 4t times 3t squared, 4 times 3, 12. T times t squared, t cubed, plus 4t times 4t gives you 16t squared. And finally, 4t times 6 would give you the 24t. Now we can take these four terms and factor them by grouping like we've been doing. So I have my first two terms that I grouped together and my last two terms that I grouped together. And don't forget about the 4t here. So actually I'm just going to go ahead and I'll write that first. And now I'm going to factor these terms by grouping. So I have 4t times the GCF of 2t cubed and 3t squared. Well, they don't have a number in common, but they have a t squared. So I'm going to pull out a t squared. And then what's left? Well, t squared times 2t and t squared times just a plus 3. So t squared times 2t, 2t cubed, t squared times 3, 3t squared. And now we'll do our second group. I have plus, because I'm going to be pulling out a positive number, I'll pull out a 2. The GCF of 4t and 6 is just 2. 2 times 2t is 4t, and 2 times 3 would give me 6. And again, you notice we have those two common terms, or those two common binomials, 2t plus 3 and 2t plus 3. So now let's not forget about our 4t. I have 4t times, and then I'm going to set up my two binomials. So I'm going to pull out the 2t plus 3 from both of these sets, or both of these groups, and then t squared plus 2 becomes its own binomial, t squared plus 2. And you can factor this as well. I would FOIL first and then multiply it by 4t. So that's what I'm going to do. Here's your answer. Well, let's go ahead and check it. I'll FOIL first. So I have 4t times, and now I'm going to FOIL, 2t times t squared, 2t cubed, 2t times 2 plus 4t, 3 times t squared plus 3t squared, 3 times 2 plus 6. And then we can see that's what we had right here. So if we pulled out 4t correctly, we should end up with what we started with. 4t times 2t cubed is, let's see, 8t to the fourth. 4t times 4t plus 16t squared. 4t times 3t squared plus 12t cubed. And finally 4t times 6 plus 24t. And all we need to do is rearrange them in standard form. 4t to the fourth plus 12t cubed plus 16t squared plus 24t, and you see you do in fact end up with what you started with. Now again, I know this is kind of a difficult concept, so don't worry, we're going to do some more examples, but we'll just have to do them in the next video.